Okay, hi to all of you. I might look orange because of the lightning. I mean lighting. Whatever. It's only for you. This video is only made for you. So, well, sorry, I couldn't really find English tasks. So, but you know, it doesn't really matter. But I just wanted to show you how to do a mixed circuit task because maybe it wasn't clear in the lesson or you couldn't pay attention. So now you may. Um, should you have any questions? I don't know. Comment or send me a text. I don't know. But anyways, let's get started. So what do we have here? I also recreate the drawing by hand so you know how it's actually done um, in the class. So we have three light bulbs and we usually name them in order, but you choose the order. So whatever, I'm going to name this 1, 2, and then 3. And of course we have a 6 volts battery voltage source. And so the first thing we see here is that these two are in series, but these two branches are in parallel. And never forget that in a series circuit, the total resistance is given by basically just the sum of the resistors. And in a parallel series, it's a bit more complicated. If you want to, I can also make a video about how we derive this formula, but it's the multiplication. So it's so you multiply the resistors resistances, and on the bottom in the denominator you just add them up, right? So the on in the nominator you have the product, and in the denominator you have the sum of the resistors. And of course, if we have multiple resistors, you just keep adding terms. But in our case, it's not needed because we don't have three light bulbs in parallel. We have two branches in parallel, and in the second branch we have two light bulbs in series. So to make things easier, let's just have a plain parallel series, and we can do that by simply simplifying the second branch from two light bulbs into one light bulb. So this is going to become R12, and this one will be R3. So it doesn't change. Okay, so we do not know the total resistance in the circuit, neither the total current or the current flowing through I1, I2, or 3. So we need to calculate these. Maybe let's go in order. So if I want to calculate the total resistance, of course, here I need R12 and R3 for that, because we know that the total resistance in a parallel series is just the resistors that are in the circuit product and sum. But here the parts are not R1 and R2, but rather R12 and R3. So we need to know what R12 is, and as I written that in a series circuit, it's basically just the sum of the parts. It's going to be, well, R1, if I, yeah, this is R1 and this is R3. So R1 is just 24. Let me write this right here. So R1 is 24 ohms. R2 is 60 ohms, and R3 is 18 ohms. So if I substitute in, of course, R12 is going to be just the sum of these two, which is 84 ohms. So R12 is 84 times R3, which is 18 ohms, divided by the sum of these numbers. Well, of course, I'm not going to do that in my head, but rather use the calculator, which is telling me that in the denominator I have 1512 ohms squared, because we not only multiply numbers by numbers but letters by letters as well. And then I divide 84 plus 18, which is 102 ohms. And just like when I multiplied, when it comes to division, I also divide numbers by numbers and letters by letters. So 1512 divided by 102 is 14.82, and ohm squared divided by ohm is simply just ohm. All right, so we do have the total resistance in the circuit, and I can use this to calculate the remaining unknown variables, which are the currents. So of course we have the total voltage right here, and since it's a plain parallel circuit, all the voltages are the same. It's constant. It doesn't change. So from Ohm's law, I can apply this formula to the total values, meaning I just add the subscript of T to all of the variables or parameters. So rearranging this equation by multiplying with IT, I get R total times I total equal to U total. But of course I want to calculate I total, so I need to divide by R total. So I simply end up with I total is given by U total over R total. And I just plug in the values and I have the solution. So of course 6 volts everywhere, so U total is 6 volts as well, and R total is just 14.82 ohms. And if I feed that to the calculator, I do end up with 0.405 amps. And I just repeat the same process to I12 and I3. I need to handle these resistors together, since now I'm in this circuit, and after I have the I12, then I can get to I1 and I2 separately. So I12 is again U12 over R12. I'm just using our derived formula but with different subscript. And if I plug in all the values that I need, of course 6 volts is again everywhere, and R12 is what we calculated, so it's 84 ohms. And of course again I use my calculator and I get 1 over 14, which is approximately 0.0714 amps. And I repeat it with I3, so the third light bulb Okay, so I do end up with all the I's that I need. Um, well, I still need to calculate I1 and I2. And I do have to remember that 1 and 2 are in series. So in a series circuit, I need to bear in mind that the current is constant, and in a parallel series, voltage is constant. So since I12 is 0.0714, I1 and I2 is equal to this. So it's constant in that branch because that branch is in series connection, which means that the voltage is going to be different. So U1 and U2 are not going to be equal. I do know that U12 is 6 volts, but what is U1 and U2? Well, again, I use Ohm's law, so I know that R1 is U1 over I1, but I'm interested in U1, so I rearrange by multiplying by I1, so I end up with R1 times I1 is equal to U1. And if I plug in the values, well, R1 is, let me check, 24 ohms multiplied by, well, I1 and I2 and I12 are the same, which is 0.0714 amps. I do get 1.7136 volts. And of course I have to repeat it with U2, which is R2 times I2 is equal to U2, just using the derived formula again. R2 is 60 ohms, as you can see on the bottom left, upper left corner. So 60 ohms times, well, the calculated current, which is 0.0714 amps. And if I calculate this, I get 4.284 voltage. And while the sum or the total voltage in a series circuit is the sum of the parts, they have to be 6, as in our original circuit as well, it's 6 everywhere. And if I add 4.284 with 1.713, I do end up with approximately 6. Because of the roundups, I got 5.997, but it is approximately. In theory, it has to be 6 volts. So I do have all the missing data. So here we have the 18 ohms, the 24 ohms, and the 60 ohms. We do have a 6 volts battery, and we can see that, rounding up, well, well, of course, we do have the 6 volts, sorry, here. We do have the 6 volts in the branches between the two endpoints, but in the first light bulb, we do have 1.71 that we calculated, and in the second one, which is the 60 ohms, we do have 4.29, and also the amps add up to I total was let me get back to it. I total was 0.4. I12 is 0.07, just like here, and 0.33, so 1/3 is I3. So yep, physics does work, and we did a great job. If you want to practice, you may practice on this circuit. Thank you for watching, and again, if you have any questions, just let me know and I'll try to help you. Bye.